thanks everyone for joining in the session from wherever you're joining. So glad to have you here and let's get started. So today we're going to talk about data engineering best practices using Azure Data Factory and Synapse pipelines. So we'll start with, we have a couple of hours for this particular session. So we'll start off with a quick introduction on the Data Factory. Before we get there, quick introduction about me. So I am Abhishek and I work as a program manager in the Data Factory team, which is part of Azure Data. That's where I am on Twitter at Narain Abhishek. So please follow me if you want to get regular updates about Data Factory. And moving to the next slide. So we will talk about a bit of context and history, what Data Factory is, in case if you aren't really aware. And we'll start off talking about data, and each of the businesses, everyone these days are going up data because data gets you insights, it gets you to learn about your customers better. It helps you improve your business overall. That's what data does. And the world is changing over time and things are changing how business is done. Data, these are some of the stats. Data will grow to 45 zettabyte in 2020. ZB is something which you don't even know. It's huge. It's beyond petabytes. And that's the volume that data is in 2020 already. So it's gone beyond that. And 80% of the organizations adopt cloud-first strategies. We know that all investment increased by around 300% since 2017 in the AI world. And AI, of course, is powered by data. You have to feed in the data to get some kind of artificial intelligence to train your systems and be meaningful out there. So those are some of the data and organizations that harness the data and the cloud and the AI outperform. This is something which we have seen. Of course, cloud gives you a lot of value in terms of converting your OpEx to CapEx. Sorry, the other way around, CapEx to OpEx. And also it gives you the scale that helps you thrive in case of your businesses are growing over time, and it makes it the whole business cost effective. And AI, of course, helps you outperform over time. And to get there, there are a lot of barriers, right? To get to the world of artificial intelligence, of being able to solve all the business problems with data, the challenge that you get is the entry, the barriers, right, to getting the value out of the data. Data are split in silos, which means data can be available, let's say in social media, right? You need to additional get the data from social media. Data exists in so many SaaS systems, right, which businesses might be using, let's say Salesforce, Dynamics 365. It's spread across different systems and sources, Office 365, whatnot. Now, it could be on-prem SQL Server as well. And then you have different kinds of data types, which does not look the same. For example, let's talk about common data model, CDM format data, which Dynamics might use as the format of data. There might be Parquet, which your Spark systems or Spark engines might be using. And they're different data, which looks different in shape. They have different schema. That is another challenge. Then the complexity of the solutions. Is it Hadoop-based solution that is doing some data analytics versus Spark-based solution versus your own solution, and so on. And then comes another challenges around multi-cloud environments. We know that customers can have their footprints across multiple clouds, and so your data can be very well be stored on Amazon, on S3, or it could be stored in a data warehouse on Amazon or Google Cloud as well. And then the rising costs, for example, if you're not on cloud, if you're using on-prem, so there are good amount of costs that you have to pay to move data across regions or move data from on-prem to the cloud. So these are some of the challenges, the barriers that we see customers facing, and you have to get through that, in order to get insights out of your data, you have to create a hub for all your data. And some people also refer it to kind of creating a virtualized data lake, where all your data can be accessed through that particular interface. Either your data lives on-prem or on another cloud. And similarly, you need to support for diverse types of data, different kinds of data. You have to have unlimited scale in your whole compute process, data integration process, and you have to use familiar tools and ecosystem, which helps you kind of lower your total cost of investment. And it should be able to connect to both on-prem, hybrid, as well as Azure. This whole solution needs to integrate the data from all the available sources that you have. Organizations that harness data, cloud, and AI outperform. That's what we started off with, and nearly double operating the margin. And this is one of the stats. It's 100 million in additional operating income is what you can expect if you are moving on to the cloud and doing AI and data integration across. Let's get to the tool that can help you do that and achieve that, which means the tool which can help you productively integrate with multiple data sources, even the hybrid data sources, and then it lets you scale out your whole infrastructure in terms of the data processing and the compute, and which you can trust in terms of certifications that it provides you, and you can get that kind of trust. And of course, there's one block missing here, which I would always like to add, is security, which is related to trust, but you get the trust because of security. So we'll talk about that best practices as well. So we'll try and focus on some of the best practices when we talk about each of these functionalities, like drag and drop UI. What are the best practices over there? So we'll talk about those as well. Now let's get started then with what Azure Data Factory looks like in your whole solution, in your whole data integration system. And so in a typical flow, you start off connecting different data sources. So in this example, you can see this line of business application feeding data into, let's say, a Cosmos DB or Salesforce, and then being able to ingest that data into whichever architecture customers want. Some people want to stage this data onto a data lake, and they call it as a data lake based data warehousing architecture. And data lake contains all the bronze table, or maybe not so, it's kind of raw data that it captures. And since data lake is quite less expensive, it makes sense to kind of store everything in there versus you would only want to store some kind of processed or information in a data warehouse, which can be used for downstream purposes, either in machine learning or either for consumption and reporting. So that's the kind of key difference between a lake and a warehouse. Now, these days, everything can be interchangeably used. Data warehouse can be used as a staging table as well, and then being processed and put it into a final tables, which can be used, like gold tables, which can be used for reporting as well. So there are different ways how customers create this. You can either use data lake base or directly use a data warehouse. Some people also call it as lake house, where you can use data lake and create the concept of Spark tables or Delta tables, and being able to completely work with that. So there are kind of variations to that, but the common part of all those is data ingestion, right? To start with, being able to ingest data from different sources, graph APIs, image data, social media data, IoT data into a common place, and then being able to orchestrate this whole process so that it's not just one time when you're building it, but it should be able to execute the same workflow, the data workflow, in every 10 minutes or every 15 minutes, and so on, based on your requirement. Some customers want the data or the whole process to be repeated every 1 minute. Some customers want it to be done every 1 hour. Some scenarios requires you to process the data or the slices every once in a day. So whatever your requirements are, there is certain scheduling that you need to do, or we also call it as orchestration, that you need to do in terms of running your workflows. And that is what Data Factory provides you. Lets you store the data either in data lake or Azure Storage or data warehouse, and then lets you transform the data, call out the transformation processes. Could it be Synapse Spark, where you're transforming this data, or could it be Databricks, or could it be just Azure Machine Learning that you are calling and getting some insights out of that data? And then finally, you are putting it in the modeling and serving layer, which is ideally a data warehouse. It could be HT Insight or Azure Databricks as well. The data lakes comes in over there. AS, Azure Analysis Services, or Power BI can pretty much read the data and kind of provide the insights to the end users and end customers. And these things can run, the whole data sources can exist on cloud, on a multi-cloud, inside a VNet, or within on-prem. Data Factory is the tool which can access data anywhere. And we'll talk about how you do that across different environments later on. And at a higher level, this is how it kind of translates to different services. You start off with ingestion from different sources. You can see that ADF is the orchestrator, which kind of gets the data from different sources, puts it into a blob, calls processes in Databricks to process them, or you can call data flows within ADF to kind of process them as well, and or use Polybase in data warehouse to kind of trigger loading into the data warehouse, and from there we can do the modeling and serving using analysis services of RBI. And ADF kind of orchestrates the whole end-to-end processes so that in case if there are any failures, like let's say processing fails, you should have a single point of view, right, in terms of debugging it. And that's where ADF comes in handy, where you can actually monitor each and every slice and get to the details in case if there is a failure. And another good part of Data Factory is that if you have invested earlier on SSIS, which is SQL Server Integration Services, for building your ETL transformation logic, you can very easily just do a lift and shift of those SSIS packages and run it on the cloud for scale. So as we all know, SSI has been there for over a decade now, and many customers have invested heavily on that. And that's the reason why SSI, as being a Microsoft tool, is natively totally supported on Edge Data Factory, and you can run in a managed runtime. The advantage here is you don't have to set up a SQL Server or specific licensing, have a specific licensing for SQL Server on-prem. You don't have to worry about the scale, the VM sizes where it is running on. You can easily create a managed runtime in ADF and execute your SSIS packages on the cloud. It can even access your on-premise data. For example, if you have your data in SQL DB managed instance or somewhere, it's awesome. The cloud ETL or the SSIS runtime can directly access that. But even if you have the data on-prem, it can still access it using the self-hosted integration runtime proxy. So you don't have to worry, even if your data is in SQL Server on-prem, or if you have already moved your SQL Server onto the cloud into a managed instance, either cases works fine with SSIS executions on the cloud. And as you know, that ADF is both hybrids. I would want to talk about that. Hybrid is what makes ADF unique is it can be used in a multi-cloud fashion as well as for ingesting hybrid data. What I mean by hybrid is on-premise data. When we work with enterprises, we understand that there are tons of data over the years which have been generated, which are on-prem. It could be log information, for example, which your applications are logging, could be in an on-prem system, or it could be your on-prem SQL Server or Oracle Server. And we understand that ideally everyone wants to move everything to the cloud, but that's ideal. And we know that ideal does not really exist, at least not in the beginning. So we have a lot of different scenarios where you have a lot of on-prem data, including SAP, Cloudera, Teradata, SQL Server, sometimes Hortonworks as well, the Hadoop systems. And you need some agent or some tool which can integrate with that as well. Now, this is the best part of Data Factory. It is a cloud service, which means it is a PaaS offering. which means you don't have to really worry about creation of a resource. In fact, I would call it as serverless billing model, which means you don't even have to pay for creation of a data factory. I will tell you an exception. SSIS is going to be slightly exception because SSIS, when you create the runtime, the billing meter starts right there. But apart from SSIS, if you're natively building pipelines in data factory, anyway, even in SSIS, you can choose to stop the integration runtime to make sure you don't unnecessarily pay the cost. But if you're building pipelines in data factory, which we'll see later, it is serverless billing in the sense that only when you run the pipeline, if you run pipeline once in a day for 10 minutes, you only pay for that 10 minutes. You don't have to pay any licensing. That's one thing. You don't have to keep paying for something when you're not running your pipelines. Now, think of a scenario where you're connecting to on-prem data stores. You don't have to pay for anything. You can run the agent. We have an agent. There are a couple of ways how you can connect to on-prem data sources. If you have heard about ExpressRoute. ExpressRoute is basically a network connectivity between Azure Data Center and your on-prem data centers. So if you have that, you can easily have line of access to your on-prem data source from the Azure, and we call it as Azure Managed VNet. Is basically the virtual network which is dedicated to you as a customer. It is managed virtual network, and hence we call it Managed VNet. And through that, you can do a private link connection and be able to access your on-prem data sources as well. And this whole setup is completely PaaS, which means once you set it up, you don't have to pay ADF or Azure, the recurrent cost. Only when you run the pipelines, it is being able to access your on-prem data and pull it and do the integration on it. So this puts ADF in a very unique place where you have a data integration tool which can do petabyte size ingestion, and you only pay for when you use it and you don't pay for anything else. So for large organizations, this becomes very, very cost effective. Imagine a scenario where you earlier had a Hortonworks, 1,000 node clusters, and we have seen customers with that and paying for that amount. And even if you scale, maybe you scale from 1,000 to 500, 500 to 1,000 back, that's the cost we are talking about, right? Savings when we talk about this data integration using this PaaS data integration service. And then comes similarly for SaaS applications, being able to connect to Salesforce, Dynamics, Workday, Adobe, and so on in an efficient manner and orchestrate this whole process every now and then. So let's talk about some ADF concepts before we get into the details. And so while we talk about some best practices, we should know some basic concepts, and we will be using these words quite often through the demo and through the session. Is the control flow. So anything that you're doing in terms of building the orchestration pipelines, which means building in multiple activities into the UI. Again, it's all drag and drop, so do not worry about the sample section. Sample section is a representative JSON of how the UI translates to them, and you absolutely need not learn that. It's more for understanding how exactly it's declared in a declarative fashion, but everything has a UI to it, and you can build the whole control flow, which means relationship between two different activities. For example, scenarios like, I want to only copy the data when the data sets are available. For example, I don't want to just run the whole flow, the runtime, and end up copying only 10 records or only 10 files. I would rather want to copy it when the destination contains, let's say, 1 GB worth files or 1 million worth rows kind of thing. So basically, you're doing a validation logic, then you're doing some data copy, and then you're triggering your transformation engine to transform the data. This makes the whole ETL system is much more, I would say, efficient rather than running it for 10 records or 1 record and 0 records and so on. So you can do that control flow, and based on the logic of the previous action or the previous step, you can take an action, what next activity you want to run. So as good as you writing code, doing conditionals, if, for each, do until, all those things are possible in a visual fashion. You can execute a particular pipeline. So you start off with activities in a pipeline, and pipeline is kind of the logical abstraction, and each pipeline can have multiple activities, control flows within it, and you can execute that pipeline, and we call it as runs. So you get a run out of a pipeline. So it's kind of a single execution of a pipeline is basically the runs. And then there are activity logs which are generated. So from the audit perspective, everything that you see in Data Factory will be showing up in your activity logs as well. It's basically an Azure functionality for all the control plane actions. Control plane means whenever you're interacting. So this is also a word which will use control plane and data plane. Data plane is basically when you're directly any APIs or interactions directly with your data is kind of data plane. And so you need to understand that that's basically interacting with your data sets. The control plane APIs do not interact directly with your data. It interacts with Azure Resource Manager. Azure Resource Manager is basically the way how Azure Services talks to the backend of Azure, but it does not interface or exchange any data. So all the control plane actions, like when you're running a pipeline, when you're creating an entity like link service or activity, will show up in your activity logs, and it's very useful for the audit purposes. In case if you need one, like who created or deleted something, you can find it there. Then comes the integration runtime. So integration runtime is basically the runtime where you run the ADF logic. It could be on-prem, it could be on the cloud, it could be on third-party cloud as well. So we'll talk about that integration runtime. And you can schedule your workflows in different fashions. For example, it can be a wall clock scheduling, where just like a clock, you can start your workflow at 5 a.m. in the morning or 6 a.m. in the morning. Sometimes you might want to define a time slice as well. So a slice between 5 to 6 a.m. is where I will run these jobs, and slicing helps you also define some backend time slices. For example, you want to start processing your data from the year 2020, right, which is already passed. So or maybe even better, 1980. You have data since 1980, and all those data are very well partitioned on your data lake. Somehow you have moved that into a data lake, and it's sitting in a well-partitioned folder by year 2020, 1980, 81, 82, 83, and so on. And even distributed by month, Jan, Feb, and so on. So you can easily set up this scheduling triggers. We call it tumbling window trigger. And you can start from 1980. What it will do is, on a daily basis, it's going to create a slice, and it's going to execute those slices in parallel. And you can start processing your data, which even goes back in time and creates slices and execute those slices, and it can parameterize those values throughout your pipeline. So parameterization is also, which we'll talk about, where you can basically make your pipelines much more dynamic in nature using parameterization. And the other concepts we'll talk about is on-demand execution. You can basically invoke a pipeline on demand rather than scheduling it. Many customers in ISVs do that because they have their own you can call it Uber orchestration system or applications, which knows what they are doing. So they can simply invoke the whole pipelines when they need it. And so a lot of ISVs use the on-demand execution through their own systems. And then the concept of parameters I talked about a bit earlier is you can create pipelines with a lot of dynamic values, and these parameters can be used to kind of substitute those dynamic values so that during the runtime, you can replace it with dynamic values, right? These are parameters. Those dynamic values can be replaced with parameters. And parameters makes your pipeline much more dynamic. It can be used in your link services, which contain the connection information. It is kind of connection to your data stores. You can say, I want to connect to that server versus this server, and it can all be parameterized. You can create a single link service, and on demand, dynamically, you can choose to connect to server A versus server B versus server C, and so on. So you can reuse the components using the parameters. Same thing can be done with data sets. Data sets is basically using the link services for connection. Data set is the actual definition of the data. For example, it's a file in this particular folder path, or its particular table with this schema in this particular table, right? So the table connection information is stored in link service, and the actual table definition and the shape of it is kind of shown, saved in the data set. So that's relationship between dataset and the link service. And then you can do incremental data loading, data factory. You can do on-demand Spark. You can do code-free UI. You can build transformations on Spark using visual UI in Data Factory. And that's very interesting because if you don't want to write code, and yet you want to scale to the requirements, to the needs of big data, we have data flows, mapping data flows, which can help you build the visual UI, which can help you transform the data. We have the SSIS runtime, and we have a code-free UI. So we'll talk about that code-free UI, and we'll call that as ADF UI or the code-free UI quite often. Okay, let's start off with the first component, which helps you ingress the data or ingest the data onto Azure, which is data movement, and talk about some of the best practices. So some of the key scenarios of data ingestion and data movement is when you're migrating data for data lake or enterprise data warehousing. And the data migration, I mean, pretty much is about big data workloads, which you're migrating from Amazon S3 or on-prem Hadoop file system, Hortonworks, and so on. And EDW is basically a migration from Oracle Exadata or Visa Teradata or AWS Redshift. So those are the two scenarios, the key scenarios that we are talking about. And why is Azure Data Factory or Synapse Pipelines useful over there is because it helps you tune the perf and scale when you're loading this. So you can get hundreds of TBs of data into your EDW when you're migrating using Data Factory. It's cost effective. As we talked about, the billing is serverless. Even the compute is serverless. It comes and goes when you need it. And you only pay when you need it. So it's pay as you go. And support for initial snapshot and incremental catch-up, which is very key thing. You start off with loading the whole data set, and then you do incremental data load on a daily basis. So there should be ability in the tool that it can simply load the whole snapshot, and then it should be able to understand the differences and then load those differences on a daily or hourly basis based on your requirement. And in terms of data ingestion for the cloud ETL, so this is the other scenario, you should be able to load data from a variety of data stores, and we support 100 plus connectors and stage for data preparation and the transformation, and then publish to data warehouse for reporting or OLTP store for app consumption. So this is the other pattern that we see, and we support rich connectors over there like file stores, RDBMS, NoSQL. It supports hybrid connectivity. You can connect to an on-prem network, get the data from there. You can even get data from a virtual network or even from a VPC data setting behind VPC. VPC is basically equivalent of a virtual network on Amazon cloud. And you can get the enterprise grade security with the Active Directory authentication, Azure Active Directory authentication, or passwordless authentication as well. We'll talk about that in security best practices. And then in terms of developer productivity, it's all code-free authoring. You get CI/CD as well for deployments across different environments. You get source control for doing the versioning of your code and so on. And it gives you finally a single pane of glass monitoring and also integrates with Azure Monitor. It's kind of consolidated monitoring system on Azure. So talking about the first scenario, where typically it's petabyte size big data migration from Amazon S3 and on-premise Hadoop systems, and then it could be TB size for the enterprise data warehouses migration, like Oracle Exadata or Netezza and so on. And so these are typical setups. Some network settings might require, might be okay with doing a public internet transfer over the public internet, and you can absolutely use Azure IR in that particular scenario. And talking about customer examples, so you can see in the first diagram. So you're requiring to migrate 2 petabytes. Very common customer requirement that we see is you have 2 petabyte data in your data lake. And you want to migrate that onto Azure Data Lake because you're moving from a different cloud to Azure cloud, and it's a migration scenario. And being able to copy this kind of data 2 petabyte of data in just less than 11 days or 10 days, right? It's no time. And people spend so much time thinking about the migration, and you can actually get the whole migration done in less than 11 days. And these are some examples from real world customers cases. If you were able to get 1.9 petabyte and then remaining in incremental or 221 TB, because things change in those 10 days and 11 days, and you generated more files worth 221 TB, and you should be able to get that incremental value as well once your whole migration is done. And so the performance, you can see the throughput in this particular example the customer got is over 2 Gbps while doing the whole bulk load. And for the smaller workload, for the incremental, because it was very well partitioned, the incremental is exactly where the data sits in, and you got a better performance. You can achieve something like 3.6 gigabytes. It's not gigabits, it's gigabytes. If you want to translate this to gigabits per second, typically that is the word that you use for measuring network throughput. So you need to multiply this value by 8. So you're pretty much getting more than 25 gigabits per second throughput when you're moving data from Amazon into Azure. So that's how performant ADF is. And similarly, for the other customer example, where you're moving data from S3 to Blob Sync over a 10 Gbps private link. And this is kind of a custom scenario where this customer is building a peering between the two clouds, AWS and Azure. It is technically possible. There are a lot of technical or network vendors which kind of lets you connect the two clouds using their own routers. And so in this particular case, we were still able to get a pretty good throughput and do a petabyte size migration, which close to 787 or close to, you can say, 1 GB per second throughput, even in the peering scenario. And this was limited because the private link or the link between the two networks on AWS and Azure, which was governed by a partner, was limited to 10 Gbps. And because of that limitation, 10 gigabits per second, which equates to around 1.2 gigabytes per second. Out of that 1.2, we could kind of leverage 800 MB, which is not bad at all. It's close to 75% of the network bandwidth utilization that we had in terms of migrating that data. So we were able to use that. And another example is someone doing an EDW migration around 25 TB on-prem, being able to move that to your Azure Data Lake systems and being able to do that concurrently. So all these things have one thing in common, that it uses the cloud data scale. We call it data integration units. And it is able to distribute that or use the distributed compute on the cloud to be able to pull this data at a very high volume. And this is where you all the three scenarios, even if it's a data lake or a data warehouse migration, it is able to achieve pretty good throughputs and get the work done in just a few days to weeks. The second scenario, I split into two, is data ingestion for code-free ELT, where you are using data flows, mapping data flows to kind of cleanse the data, dedupe the data, and then even transform the data and load that into a data warehouse. And so you need the data from your on-prem systems, cloud data from different clouds, the SaaS data, and then run the transformations on it, very common. And then data ingestion for code-based transformations. For example, you already have some scripts and stored procedures which does the transformations. So similarly, you might continue to use that even on Azure. If you're doing, let's say, a notebook or preparation using writing custom code in a notebook, and that's what you've been doing earlier on the cloud, you can continue to have that on the Azure cloud as well. And ADF can integrate your notebooks with Databricks or Synapse Spark, or even run your stored procedures for transforming it in the data warehouse directly. So you can choose either of the patterns, where you can use code free or you can use code based. Many customers choose to use code free because it's easy to maintain and manage, rather than writing codes for managing all your big data processes. And those are those options. On the right hand side, you can see functions there, especially if your data sets are small. and your processing requirements are small, you can use that. You have HD Insight, which is a high-fig Spark, MapReduce, streaming, all those things supported over there. It's primarily Hadoop based. You do have a Spark flavor too. You have Synapse Spark as well now, and you have Azure Databricks, which can run your notebooks, jars, Pythons. And then, of course, the stored procedures runs on SQL Server and SQL DB and SQL Server did Synapse Analytics as well. And then you have the Azure Machine Learning and Azure Batch Service. Azure Batch basically lets you run your custom code. So if you've written some custom code in .NET or in Java or in Python, which is not Spark based, you can pretty much use Azure Batch over there and execute those whole thing through orchestrate that whole batch component through Data Factory. Okay, now some of these concepts which we earlier touched upon. So we talk about things like copy activity, which basically is the data movement activity. We start off with a trigger, which you see on the left-hand side over here. So there's something called as the trigger. So let me use the highlighter. I'll use a laser pointer, yeah. So we start off with a trigger for the pipeline. So trigger is basically the one which kicks off the pipeline logic, and you can make your pipeline much smarter if you have a smart trigger. So we have added event triggers, which makes your whole data pipelines event-based. So we were already kind of a pass pipeline or a serverless pipeline, which gets executed when you need it. But now you can even add that smartness to say that start my pipeline only when the data arrives. So we don't have to get into a polling logic where we start to compare data and then start to run your pipeline. So you don't have to get through a definition where you say my pipeline runs every 1 hour. Rather, you can say when my data arrives here, start my pipeline. That is the event-based systems that we integrate with on Azure, and being able to execute your pipelines and workflows based on when the event or the file arrives. That's a very, very important thing on cloud. It takes us to the next level from saying we were serverless. Now you can be smart and serverless at the same time with making your pipelines run based on events that you pass to the cloud, or when the files get generated, it can start your flows. Apart from the tumbling window and the schedule trigger and the on-demand, which you already supported. And then comes the pipeline. The next step, this is where you declare your workflow, the dependencies, and so on. And from there, you can have data flows transforming the data and different activities. And you can have for each all the programming artifacts, all using the UI, visual UI is what you can do. I see a chat question. Maybe let me quickly talk about that after the slide. And then you can build this workflow in a fashion where the green arrows, you can see it's kind of a non-success activity execution. And the red ones is when this previous activity fails. Let's say my transformation logic failed. And now I want to do a cleanup based on because my transformation failed. Or I want to trigger an email notification, or I want to send a Teams notification based on this failure that happened. And you can do that, like you can set up a condition saying on failure, call this one on success, call this flow, and so on. And then comes the different link services, which are nothing but the connection information to different sources and sinks, and which runs against runtime. And there are two kinds of runtime. One is self-hosted, as the name says, it's hosted by the customer, by you on your machine. So it's not really serverless because it's hosted on your machine, but that's the best we can do because self-hosted IR gives you the freedom of running it anywhere, governing it any whichever way you want to govern it. If you're using your own, like how you govern your own virtual machines or your own systems, you can integrate this whole runtime with that particular governance process. The only drawback that you get when comparing with the Azure IR is serverless, which means we can create a number of nodes on demand. Self-hosted IR is more like a pre-created by customer and installed, though we manage the auto updates. So we can still manage your runtime updates automatically, but you will need to provision it on your virtual machines. So that is something which you will have to do the setup on. So those are the difference between self-hosted and Azure, but self-hosted certainly gives you that freedom of setting the runtime, meeting your compliance requirements and regional requirements and whatever. So all those things can be possible. Whereas Azure IR gives you humongous scale and value in terms of being serverless and truly serverless on cloud. And before, let's take up the questions. So I'm just going to quickly, 1 second, show off this. There's a pointer, the question. So we have a question. Okay, it's more of a suggestion from Adrian, which we suggest that AS makes sense more for big data. Example, when the volume of data per model is more than 100 to 200 GB. Moreover, Power BI needs to use direct query for AS. Yes, so that's right. So AS certainly makes more sense, but we do see customers using Power Query as well. I mean, using Power BI as well with those big data ones. So you have both those options you can use along with in your data integration flow for the analytics part. Getting back to the connectors set, we support 100 plus connectors, and this list keeps growing over time. So next year, I remember last year when we talked about it was 90, now it's 100, so it keeps growing over time. And so these are all a bunch of connectors which will not go into detail. Some of them are supported as both source and sink connectors. Some of them are only supported as read only, which means source connectors. You can see the different color marking for that. And connectivity to additional data stores, we have generic ODBC connectors, which means if you have a particular data store and that particular data store is not listed in the previous table, you can always get a generic ODBC driver or connector and use that to connect to your specific data stores. That is possible as well. So I wouldn't want to call this as extensibility, but many vendors already call this as extensibility. So that is an option that you always have, to use a generic ODBC and get the connectors from your vendors, and they can provide those drivers. ODBC drivers can be installed within ADF, and ADF can connect to those specific data sources. So that's one way. The other one is for the SaaS applications. They typically have a very well documented RESTful APIs, and you can use generic REST connectors over there to access those data stores. And there are SOAP APIs as well. So you can use generic HTTP connectors. All these are native connectors in ADF. The generic ODBC can be used for extensibility for database and data warehouses. Then you have REST API connector, HTTP connector, and generic OData connector to get the data from OData feed. So that's how you extend to any SaaS apps which are not even in that list of 100 connectors. So that's how extensible this framework is. And for the custom, part where you can actually have all these files which are on Amazon Blob, all those native connectors already something which we support. But at times, customers can use Azure Functions or custom activity to build their own native connectors if they don't meet the requirement in the first two steps, which is being able to bring generic ODBC driver because they have a custom implementation. Then you can always use either Databricks and use that to push the data to the cloud, or use HD Insight, or use your custom code as well. So these are the three ways you can extend the support to any data store. We briefly talked about Azure Integration Runtime, which is managed serverless pay as you go. And so you get that flavor with Azure Integration Runtime. It can do auto resolve, means you don't have to worry about specifying a region over there. It can be smart enough to understand where your data is sitting and being able to use that region. But if you want to explicitly override the region, say, because of my compliance requirements, my data in North Europe should always be processed through a North Europe-based compute, whatever it is. And then in that case, you can define a region to your Azure Integration Runtime, say region is North Europe, and it'll ensure that every time that you run your workflow against that connection in that data store, it runs in that particular region. Managed virtual network is another feature that we added in terms of security, which helps you connect to your data stores using private endpoints. It does not go through internet or even not through the Azure backbone public internet. It goes through, a private network, 1:1 map to your data store. So it's certainly much more secure. And you can specify the DIUs, the data integration units. In case of data flows, transformations, you can specify the core counts that you need for transformation in the integration runtime as well. And then the default behavior based on your data pattern, it kind of is able to apply the smart defaults to get the best performance by default. So if you don't have to worry about specifying DIUs as 2, 4, 8, or some numbers, we will automatically assign certain DIUs after we have a quick look into your data sources, and we can do that auto tuning for you. So that's the best part. But if you're a pro user, you understand each of these knobs and you want to control them, you can go ahead and specify the DIUs that you want, and we'll provision those DIUs during the runtime. And the self-hosted integration runtime is something which you install on your on-prem, or you install it on Azure VM, wherever you can. You can even install this on Amazon Cloud to push the data from Amazon onto the Azure side. It is touchless in the sense it supports auto update. So once you install it, that's the manual work, but it'll automatically integrate, or update the runtime. We typically update the runtime once in a month. So every time it has an update, it'll pull all the changes locally and update itself by default without you having to worry about job failures and so on. It supports high availability and scale out. Those are typically enterprise promises, which kind of it meets. The next thing is the single node concurrency. You can actually have concurrent job executions on a single node. It helps you do cost savings. Be careful while doing that it can also overload your systems because you're running multiple jobs on a single node. So it's not always a good thing to do. But if it's a lightweight job, that actually works out very well. Some of the best practices while doing data movement. So while extracting the data from file sources, there is a concept of DIUs. So those DIUs, or that translates when you're using a self-hosted integration runtime, there is no DIUs because DIU is kind of only applicable for the serverless runtime. For the self-hosted IR, it translates the number of nodes that you have. For example, if you have 4 nodes and if you're reading 10,000 files, versus if you have 1 node, which is reading 10,000 files. So of course, it's going to be 4 node, it's going to be distributed across 4. So each node reads 250 files, it's going to be 4 times faster. In case of DIUs, if you use 4 DIUs to read the data from across 1,000 files, versus when you use 16 DIUs multiplied by 4 across the same number of files, you'll get 4 times better performance. And if you increase this DIU to 8 times by using 32 DIUs, it's going to increase its performance by typically 8 times. So that's the performance gains, and those are the best practices. We typically suggest you to leave the DIU as auto, and if you're using self-hosted IRs, use as many nodes as you can, up to 4. If you're the other best practices around resilience. So whenever there's a failure in a particular copy activity, you can rerun the failed activity from the point of failure, which means that if you have copied, let's say 80% of your files, you can resume from the 80% of the files that you've already copied, and you can skip copying them, and you can resume from the remaining files. That is the level of resilience that we actually give you. And failures, of course, can happen anywhere. It can be due to user error, or it could be due to system error, networking issue, whatnot. But imagine you're moving petabytes of data, right? And failures are bound to happen. Network failures are bound to happen. So we should have a resilient solution, right? So ADF helps you rerun your pipeline from a particular failed activity as well. And then extraction of data from non-file sources like databases, NoSQL, SaaS applications. It optimizes out of box for Azure SQL database SQL MI, Synapse Analytics, Oracle, Netezza. So these are some of the common data sources, and it optimizes that. And on top of that, you can use a query to get incremental data or use some partitioning option in case if there are physical table partitions or there is a dynamic range which can be used to get the partition in terms of the query for scale. You can basically do that, and you can then scale in terms of parallel copy. So there is a concept of DIU. Basically, it increments the number of cores that we use to pull your data, and then there is a concept of parallel copy settings as well, which basically defines how many batches you want to read on each node. So each node can actually start with 2 batches, 4 batches, and 8 batches, and so on as well. That's what the parallel copy settings are on top of the DIUs. And you can basically use this parallel copy settings to kind of improve your performance as well. Just like how you use it in Scoop and other tools, you can have the similar copying per partition by increasing the parallel copy. You can do incremental extract from file sources as well. And how you achieve that is using certain expressions. So the things that you see here in red are nothing but expressions in Data Factory. So you can define expressions. These expressions will resolve to values during the runtime when you're running your pipeline. For example, the first expression you see here is it says you can do either load all files or you can load files from last modified time. What it does is it auto-generates these expressions when you select these options in the loading behavior. When you're using the tool, the copy data tool for doing that, it will auto-generate these expressions for you. What this expression means is during the runtime, it will take the pipeline parameter, like the window start time. When you start this particular pipeline run, it will use that as the window start time. It's kind of a system variable, and it will create the year, month, day format, and it will format that into a structure. Like example, if it's today, it's going to be 2021, and then 10, and then the day, right? Whatever the day is, and it's gonna substitute this value and check for your root folder name and then slash and then put this particular year, month, day format into that, append that, and then dynamically access the files inside that particular folder. So this is how it can dynamically read certain partitions. Sorry, it's not portioned folders, but partitioned folders based on a specific date time format. Similarly, for the non-file sources, it will use the same logic as well, where it will construct queries, start time using a start time and a last modified time. So you can see it can generate query like a selects star from where the date was modified between this time zones where with an and cause. So this basically will help you push a particular based on a timestamp, pull only data from that particular timestamp till current date time value. And this is how the pipeline would look like. You will have a lookup to get kind of old watermark. What was the last watermark that you successfully copied? And then get the new watermark as well. What new watermark could be just the current date time as well. And then do the copy, do the delta generation of the query above, which we actually, the UI does that for you. So you don't have to worry about it. When you're using copy data tool, we'll generate this whole thing for you. But just for understanding, because when you talk about best practices, you should know how it's working so that you can change these values accordingly. And then when it comes to copy, it uses this dynamic query to generate the query based on the old watermark and the new watermark. And then finally, you'll need to update the watermark as well in the system, because your lookup in the next run will use that watermark. So the last step, or the final step, is to kind of update this watermark. In this case, it's using stored procedures, which means the watermark tables are stored in a separate table in a database. And then the other thing is data is small in size. You can always do a full or a copy overwrite if it's small size data. This was for incremental column. If you have a timestamp column, you can use the timestamp directly. You can have a source as change tracking enabled. You can leverage change tracking or CDC as well. In terms of performance, this is just a quick table of the experience of the time that it takes when you're moving data, right? And this is also assuming that you are getting a certain amount of performance. For example, 50 Mbps, you can see for 1 GB of data movement, it takes about 2.7 minutes. It depends on multiple other factors as well, because you need to have the runtime with the scale and so on. But it's kind of ideally assuming that you have runtime of the highest size, and this is the max throughput or the time that it would take to move this much of data. So if you're getting kind of 10 Gbps throughput, you can move like 1 petabyte of data in kind of 0.3 months, which is just maybe about 10 days. 10 days or so. Yeah. So this is what gives you an idea of when you should go with the online versus offline data movement, because there are a lot of questions when it comes to data migrations. Should I go offline using different technologies versus I do it online? So using ADF is kind of online. And if it does not meet the stable requirements, or if you have requirements which requires more throughput, or if you have the offline data transfer mode faster than this, then you should use offline. So that's basically about that. Understanding how the copy activity scales. So copy activity, when you're using a self-hosted integration runtime, you set it up on 4 nodes. If you're using Azure IR, we'll scale it up based on the DIU that you suggest. You don't need to worry about it at all. Just give us the DIU value, or let us figure out the DIU for you, and we will create equal number of nodes in terms of number of DIUs, and be able to scale up your whole copy process. Then comes the identification of the issue problems. For example, monitoring your pipelines. Once you build it, let's say, how about understanding issues? How about improving the performance? So when you're running in the monitoring section, you will see suggestions. You'll see performance tuning tips, which basically tells you a lot, saying what is the issue? How can I improve performance further? You can see in this case, you're getting a throughput of 2.8 gigabytes per second. Which is pretty good, which is like 20 Gbps, small b gigabits per second, which is already pretty good. Now, why is it? How can you improve that? And you can see on the top, it shows the 6 write operations were throttled by the sync data store, which means you are able to read all the data from your source S3 well, but the writing operations are more expensive and it's throttling your storage. And it gives you some suggestions on how you can improve that, on the storage side, on the Gen 2 side, or you can reduce the number of concurrent copy that you're doing. You might be copying multiple data, or your storage might be heavily being used by other applications as well, which might be throttling it. So it kind of gives you those suggestions saying to make it more performant, you can improve some things on the storage side or decrease the DIUs on ADF side to make the whole data movement more cost effective, actually. So those are suggestions that you get here, performance guide. And for the integration runtime, you can also quickly check. This is for the self-hosted specifically, because Azure, you don't have to worry. It's managed by us, created by us, it's serverless, but the self-hosted IR runs on your machines, and you might need some understanding on what's going wrong if something is going wrong. And so we actually show you some stats, whether it's high availability mode is on. You can all do all those monitoring from the cloud system as well directly. You can see the number of queue length, the number of jobs which are waiting on that SHIR, which is the queue length, the average queue duration, how long on average a job has been waiting. These 2 values give you a good understanding whether you need to scale your self-hosted IR or not. And then a very important thing as a best practice, I would say, is building metadata-driven pipelines. And what I mean by metadata-driven pipelines is keep your logic as dynamic as possible while building those pipelines, so that you don't have to hard code things in the pipeline, so that you don't have to create n versions of your pipeline for each of the data stores or each of the databases. What customers ideally want to do is create one pipeline, a generic one, as generic as possible, and share it with your team, right? So that everyone can use the same pipeline and then work on top of that, rather than creating hundreds and thousands of pipelines and then getting into this world of managing each of those pipelines, because each one of them are different in nature. So the good idea is to kind of build a metadata driven pipeline where you start off your pipeline, and that metadata tables, you create a metadata tables. In this case, you can see on the table on the top, which contains like SQL Server name, the database name, the schema of the table name, the file names, and so on. The watermark column, the watermark value, all those things are kind of logged in a metadata table. Now, the advantage you get is you don't have to create n pipelines for each of those source table names with different data sets and different link services. You can create ones and read these values from a lookup activity. We call it lookup activity, which can look up in your metadata table, get all these values once, and then do a for each and execute pipeline. So if you get 5 values from your metadata table, it's going to call 5 pipelines internally. If you get 50, it'll call 50 pipelines. So you don't have to dynamically or statically declare all those 50 pipelines at once. Rather, you would use this metadata driven table to feed the value into the pipeline, and the pipeline will be dynamic in nature. So each pipeline itself also does a lookup. As you can see, you have 2 levels of metadata. One is list of all your tables. The other one is for a specific table. It can fetch watermark values for that particular table value, and then do the dynamic parameterization, which we saw earlier, create expression, which can do a dynamic query and get your whole data movement accordingly. And you can have a logic within that. So you can see 3 levels of pipeline. One is a main or the master pipeline, calling a particular copy pipeline. And within the copy pipeline, you're using something like a watermark to get differential copy or the incremental copy, and then updating that watermark. So you can build this kind of pipeline. Though it sounds complex, it's extremely easy. We have templates which already have these logic packed in. You just have to create connections to your database and to a metadata table and so on, and everything works from scratch. Okay, let's talk about a demo before we move into the transformation. So I'm gonna quickly take you through some of them. This is how Synapse Analytics looks like, and Data Factory looks very similar as well. So you can see this is Data Factory. Data Factory and Synapse Analytics. I'm talking about Synapse Pipeline component in Synapse Analytics. Looks very, very similar. It's actually the same thing. Both uses Data Factory. This is Data Factory standalone, and this one is Synapse Analytics. So you can use either one. The concept starts from Integration Hub, and you have all the pipelines in that. And you can see this is one of those pipelines which does the Delta copy from a database. And this is how the pipeline structure looks like. You start off with yes. So I have a question, and I will talk about that later on in the next 1 hour that we have. We'll talk about the GUI based Spark transformation, the code tree, which is data flows, and I'll get there. And to also show you something, I mean, we already have that, which we will talk about in this, is the data flow transformation. So we have all the data flow transformation, which looks something similar to this. Let me just quickly enable this guy, the debug data flow. So this is how the visual transformation looks like. If you're coming from Informatica or SSIS world, you'll find it very familiar. You have this UI, and you can start off, with your source, and then you can write all the transformations. Like here, we're doing join You can do inner, full outer, left outer, all these things. You don't need to literally write any script or code. This is the visual UI, which I was talking about earlier, and we will do a deep dive into this in the best practices there as well. But just to give you an idea, yes, there is a visual UI, and you don't have to write Spark code at all. You can declare data flows, which is basically visual UI, and you can do all the transformations using the visual UI over here. So you can simply do joins, you can add more steps, you can see all these transformations that you see. You can create a new branch of your source data and start transforming. You can do join, conditional splits, exists, union, lookup. We'll get into each of these steps and best practices there as well through this session. Okay, before we get there, let me just go here and quickly turn on a few things. Yeah, so we were talking about the metadata-driven pipelines, and this is one example. And by the way, all these are available as templates. So when you click on this, you can browse gallery over here. And in the gallery, we have a bunch of templates, which you don't have to start from scratch. For example, bulk copy from files to database, copy Dataverse data from Azure Data Lake to SQL DW. So all these things, the bunch of templates which are already given based on use case, copy new files based on last modified time, customer feedback analytics. All these are tons of pipelines which you already have here, and you can quickly get started. Send notification to a Teams channel. All these are very well packed templates, and if you want to create it, you can simply click on it and get started. For example, I'm going to create send notification to Teams channel. Because on failure, I would want to send notification on the Teams channel. So I click on continue. It tells you about the template. You can view documentation. We typically add documentation for each of these templates, which will give you much deeper understanding about those templates. But even if you don't read them, we try and make it as simple as possible. So when you click on open pipeline, we will simply add the pipeline over here. You can see what those pipeline contains. We have already added that now. And it calls basically the Teams webhook. You need to pass certain parameters so you can actually see it. It's very well, it already creates certain facts. Facts is basically specific teams that it needs to send. So it uses certain variables, it writes certain expressions. You don't have to worry about it at all. All the code and the things that Teams requires in terms of the payloads are already written in here. It already is well parameterized, uses an expression. It uses the pipeline run ID and stuff from your previous pipeline, which has been calling, and it parameterizes all those things. All you need to do is from your pipeline, if you want to integrate it right here, let's say from this pipeline, I want to do is when it fails, I want to send a Teams notification. What I can do is click here, add on failure, and I can drag an activity called execute pipeline in here. And I can say on failure, execute pipeline 1, and I can name this as send Teams notification. And simply execute that pipeline, which I just dragged and dropped. So search for send Teams notification. Now you will see that it dynamically creates certain values because it's a template. Template means it has parameterized a lot of things. And so I need to simply specify some of these values, like where the subscription, what's the subscription, because what it does is this template, it generates a monitoring URL for your pipeline, the specific pipeline that you are right now in. And to do that magic, it needs a few things like your subscription name, your resource group name, your pipeline run ID, and so on. So all those values, you can see the default values override the value from the particular pipeline, and all those things are fine. And the values which you see as update value are the ones which you need to update for sure. Otherwise, your pipelines generated or the links generated will not work fine. But for the other ones, overwritten, you don't have to worry about it. We will automatically pass these values and names to the activity. So just make sure in this parameters, just make sure that the ones with the brackets update value are updated. The remainings will be done. And this assumes a failed status by default. So if you want to change the status in the message to fail to success, you can go ahead and change things inside this pipeline. But that's how simple it is using templates, right? You're kind of working on top of what is already there. So getting back to this thing, you can quickly get started by saying copy data tool. And copy data tool, when you click on it, it gives you a visual UI saying you want to build copy task from scratch, or you want to do a metadata driven copy task, which is exactly what we saw in the best practice, how you could create metadata outside and being able to use that metadata to build the framework. And you can design this whole in a very visual wizard kind of a fashion. You can set how often you want to do this trigger. You want to do a schedule trigger, or you want to just run it once, right? And you can basically assign schedule trigger, set all the time that you want to run it, or you can just keep it this way. When you select the metadata driven copy task, you get to select what control table you want to use. And this is the best part. You can generate a control table outside of ATF and keep updating that over time, or your applications can update that, or other ATF instance can update that. Whatever logic you want to use, you can do that. That's the beauty you get when you use an external metadata table. It's more like having an external Hive meta store in your Spark engine, and that's the same value that you get here using the control table, which can be externally stored. And you can create one, or you can use an existing metadata table, specify what table your metadata values are coming from, and or you can even say create new table. What this does is we actually simplify this metadata driven framework by saying we ourselves using these pipelines can generate metadata based on every run that we do. So you don't have to worry about creating stored procedures. You don't have to worry about for updating the metadata values. We will do it for you, and don't worry about it. You can just give table name over here, control table or something like that, and rest will be taken care by us. So we can do dbo.control table and click on next. Oh, I'm sorry. So it uses an integration runtime, which is offline. That's my bad. But you can create a new integration runtime or new connection here to any SQL server. And then basically be able to do that as well, like using that control table. So that's the value add you get. You can configure your source, your targets, your settings, and so on. All those things can be done right away through this particular visual wizard. And it'll end up generating pipelines which look like this. This is what it generated. There's a lookup table. You don't have to worry about lookup, but what that wizard ends up is generating a pipeline for you. You don't have to worry about it. You don't have to worry about the expressions it uses over here. All those things are taken care. There's a for each activity, which has an inner activity of the copy data, which has certain values. So it has expressions like schema, the name of the table. All those things will be dynamically specified by once it reads the metadata table. So all those things are taken care of in the metadata driven copy. So that's the value that it adds. Now let's get back to transformations, the visual transformations that we talked about earlier. And this is basically more of a build your solution, the processes, the best practices on how you go about it, assessing your data, functional understanding of what tool you should use, doing a performance POC. And I'll share this slide deck. Of course, the session will be recording and the decks will be shared, so you can access this and use it offline. Let's talk about visual transformations for a bit. And then these are data flows. We call it mapping data flows in Data Factory and Snaps pipelines. And these are code-free transformations which scale because it runs under the hood on Spark. So it gets best of both the worlds. You get visual transformations as well as it under the hood runs on Spark. So it can scale out to any amount that you want in terms of your data growing in size. And it is resilient flows, handle structured and unstructured data, semi-structured data as well, operationalized as a data pipeline activity. And it's much better than writing code, but both options are available based on your choice, whichever option you want. You want to write code versus you want to do this in a code-free fashion. So you can see on the left-hand side, you start with a task, which is your source. You do a lookup keys based on another table, dimension table. Then you do a column selection. You do a new flow out of that, and then you do a surrogate key transformation, and then finally you output that into your sink. Now the same thing can be done using code as well on over multiple lines and so on. So whichever way works fun. We're right now talking about the code-free transformations, which can do things like data cleansing, validation, aggregation, literally everything that you would expect to do with code can be done with data flows as well. So how it works is ADF data flow, the UI designer generates certain data flow scripts, and these data flow scripts gets translated into a Spark code during the runtime. So everything can be monitored using the ADF visual UI. So everything is visual, from authoring to monitoring. Everything is basically on the UI. Okay, now this is where it fits in the MDW. We revisited this picture earlier. So now you can see that in ingest and transform, you don't have Databricks and Spark and so on. You can have data flows, both wrangling and mapping data flows, which can do either preparation. Wrangling is basically the Power Query based data flow, and the mapping data flows is where you would, start from source, more like the Informatica or SSIS kind of a data flow, and you can use either one of them. Both can help you do a visual transformation, can help you enrich your data before it kind of puts it in a serving layer for Synapse Analytics. Some common scenarios, SCD is a typical pattern, slowly changing dimensions with the big data world, and especially data coming from, we face this quite often, an ISV who works with multiple different service providers or customers have this common challenge that the schema of the data differs a little bit. And what they want to eventually do is merge it into a common data warehouse table, because it's coming from their different customers, right? But the schema is changing over time when they onboard a new customer, slight change in the schema or so on. And this brings in this concept of your data schema is changing over time. There's a new column being added, or additional current column being modified with the data type into something else. Now, this is where SCD kicks in. And with data flows, if you didn't have data flows, things will fail because it's not able to interpret or infer the schemas from source to sink. But data flows is smart enough to take care of that. So it's very, very commonly used in big data world, and data flows can support that. If you have a new column all of a sudden appearing in your source, which is not controlled by you, you can manage that with data flows. It can compare the columns and then be able to add new columns and so on in a visual fashion. You don't even have to do anything strange. You can just check that box called support change and so on. So it can actually take care of that. The other pattern is the fact loading into a data warehouse. This is also commonly used where data flow is actually being used in. So you can start with the fact source and then being able to transform that, cleanse it, look it up based on your dimension tables. For example, all the dimension tables you have, do certain joins, enhance the particular data set or data frame, and be able to write it into your fact table, the final fact table that you have. Then is the metadata validation rules. So for example, you have certain metadata that you got out of a copy or you got out of your system applications, which you want to do a quick validations, whether the files have been correctly written or not, and do the validation or even generate a log out of it. You can actually use data flows for that. So think of this is also one of the scenarios, and there's a link which basically Mark did on the YouTube. So you can find a lot of these examples on metadata validation tools with Data Factory. If you search by those keywords, you will find a lot of videos on that. We will get to the data ops part towards the end of this. So I'll make sure that I have at least 10-15 minutes left towards the end to talk about data ops and best practices there and how to do testing of your pipelines and so on. Then comes the data deduplication and distinct rows. Very common scenarios, you want to dedupe the data, duplicated rows that are coming in, and make sure that only the distinct rows stay. And all these things are available, again, as I showed you, the template gallery. Template gallery contains these data flows. You don't have to even build this visual data flow by scratch by yourself. You can simply use it from a template. Templates supports export and import as well. If you modify it, you can choose to share it with your teammates as well by doing a quick export of the template and importing it locally as well. So those are the beauty that the visual UI supports. You can do data profiling to understand how the performance looks like when writing different rows and so on. And then for authoring your data flows, you start with a dedicated development canvas for data flows, and you start, it's kind of drag and drop click visual transformations. You start with the source, add different transformations, like here you're doing certain join, and then you're doing a surrogate key transform, joining it with another stream, and then finally adding it to a dimensional table using pivot or unpivoting the data that you have. So, and it's all visual based. You can specify the conditions in text boxes, as you can see here. And you can build all your transformation logic. It contains 19 are currently available in terms of transformations. And we keep adding, again, it's like we add connectors, we add more transformation logics as and when we hear requirements from you. And the core logic of data flow, you can add, remove, alter columns, you can do joins, lookups from data sets, you can change number or order of rows. It's very useful in reporting. Aggregation of data is something you can do and output the aggregated data into final tables. Hierarchical to relational conversion of data sets. For example, a very common use cases that we see is if you have data in the Cosmos DB world, which is hierarchical JSONs. Cosmos DB is a document store, so it basically stores your JSON. And you could have examples where you have really complex JSONs. And I probably have an example which I can actually share as well. And that kind of hierarchical JSON ability to convert that or flatten that data out so that you can store that in tabular form for reporting is very, very critical, especially because you cannot, it's not so easy to analyze hierarchical data, especially when it goes to n levels, right? So those are some common data engineering challenges. Quickly get to that before we get back to the slides. Here's an example which I would want to share. Let me just go back. So here's one example which I would like to show when we talk about hierarchical to relational transformations. This is one of the examples which I feel demonstrates about it is Zillow is basically one of the data sources from the real estate world. And it's coming from an application, real estate application. And it's generally applications will use JSONs to kind of have the data in there. And so it's kind of a very complex structure of JSON. It's kind of array of JSON. And if you look into the projections, you can see of this particular data, it contains a body and headers, and you can see its complex type, an array in the body. If you dig deeper, it goes deeper. It's a JSON which has a body and headers. Within the body, it has data tables and some metadata information, which contains column names, which, no, it's actually next cursor ID, which means if you want to read the whole data set, you have to go to this next cursor ID and get the next data frame out of it. And it's a complex operation. But now with data flows, we can actually understand we have a REST API connector, and it understands how REST API works, how the metadata works in the REST API, and it can actually go ahead and read all the cursors that you have in a REST API and retrieve the whole large data set out of it. That's one problem that it solves. Second problem is you can just focus on your transformations. You don't have to worry about next cursor, how the data ingestion works from REST API. Then comes the data, the actual data. You can see there's column names, name of type of columns in one of the arrays. And then there is another array which contains the actual data. So you can see it's 3-level deep, right? And it's all JSON. And I can actually show you how complex this whole data looks like by simply going here. Maybe I can do a preview and just let me edit this. Cancel REST API. Yeah, I can construct this URL just to show that. So this is where the data comes from. So let me just start this. In the meantime, this data flow runtime loads. I will typically show you how this data looks like. Okay, so this is how it looks like. And this is a common data engineering challenge, right? So this is how it looks like. You start with something like data table contains data, and you can see how complex it gets. And then there's an array, which 4 different columns in it with date timestamp value. This is kind of a decimal. This is certain things like string, and you need to infer this as well and flatten this out and maybe get only these 4 columns out into a database, right? That's it's a kind of a typical challenge. Now let's see how Dataflow handles it. So we start off with this source and we create a REST source out of it, and you can go ahead and do a data preview at each and every step. So it's as simple as saying, here's a REST endpoint, get me all the data, right? And then start flattening it out. So we have a flatten transform as a next step to kind of unroll this array based on particular value that we want and get the data flattened out. And then we will derive a column, add a new column, remove certain columns, and simply output into the data warehouse. So just wanted to show you how the complexity is and how it simplifies this whole complexity. This is where we started off with. It has a body, inside the body, you have data table, metadata, then you have a parallel headers. We are more interested in getting the actual data. So if you click on it, you will see columns and data. Inside data, you have the actual data and column names gets from here. So if you expand, you can see it is array of data. It contains within the data, it has multiple values. Each value contains all the 4 rows in it, right? So we want to transform this into a single table with 4 columns, as simple as that. And how we go about doing that is we add a flatten transform as a next step, and we unroll it by the structure. So as you remember how the JSON looks like, it starts with body, data table, and then the actual array of data. So we unroll it by that path, and all these things will show up here in the dropdown itself. It's all visual. So you can select on what basis you want to roll. For example, I don't want to do it for columns. I want to do it for the actual data. So I select this column, and you will see it generates this body.datatable.data. You don't have to understand what this is. Simply just select the path, the route that you want to unroll it by. And it gives you what that thing here is. So you don't have to change anything here. It already uses that curly braces to unroll the route from. And then it maps it, for example, into 2 columns right here. So the column names, if you want, you can delete it. I just kept it here, as well as data tables. So this will improve a bit because you unrolled it 1 level, but it's not ideally what you want. You want to simplify this further. So just for the example, I just wanted to do a quick data preview and show you how it looks like. It has now 2 columns. So we have reduced 1 level of parent already by unrolling it. And now you have 2 levels here, and you can see that the data directly can be accessed through the data column, but it's still an array, right? So what we will do now is we will map these 4 columns directly using a derived column transform. So here's a derived column transform. Here's the column name, which can be dynamic as well. In this case, I just use static values and said that for the data array, I can directly use this expression here and say data 1, 2, and 3, and 4, because it basically has the four values in it. So I specify that. Now, if you do a quick data preview, you will see that we have already unrolled it and flattened it and derived it into new columns. So from that complex JSON, now you can see that it already emits out these 4 columns, but it does append it to the previously valued columns as well that we got in the previous step. And so while doing the mapping, you can reduce that and say, I don't want those 2 columns and I only want these 4 columns over here. You can do auto mapping as well. It will map those 2 columns as well, but I purposely remove that. Now, if you go ahead and do the data preview, in just 4 simple steps, you were able to translate that complex hierarchical JSON data into a much more flattened tabular data that you want. You can append, new timestamp columns as well when you process these data and so on. All those things can be done with the derived column. For example, in the derived column, you can go add a new column and add an expression. So you can do a pattern-based expression, which basically is very generic. Or you can, if you know exactly a column name that you want to create, let's say a timestamp column, you can actually do this and specify a particular expression here. We have an expression builder. You can say time, UTC time, or is timestamp to timestamp, current timestamp, something like that. So what this will do is it will inject the current timestamp into your data set. So I can quickly do a data preview here. And you can, this also gives you expressions when you're writing expressions. This is the little bit of code part, but you can see that it can actually give me a timestamp like this. You can format it as well if you want to format it, or you can leave it as it is. Now, what this will do is when you do this data preview in the final step, let's use the final step, this one, and do a data preview here. What you will see is instead of the 4 columns, it now adds a 5th column. Oh, actually, I haven't done the mapping here, sorry. So come back here, just do the auto mapping once, add mapping, fixed mapping. I will select the column name, which was the timestamp that we added, and call it timestamp. Now go to the data preview, hit this button. What you will see is we have so easily transformed this data and also left timestamp column to it so that we can identify for audit purpose that this is the time that it was transformed. And you can then write it back into the database or data warehouse, right? So this is how simple it is using data flows, visual transformations to work with different data sets, cleanse it, prepare it, and then bring it into your database or data warehouse. So I will get back again to the slides. 1 second. So we talked about those transformations. We saw data flows, how you can actually use that. We'll talk about some best practices with different kinds of transformations that we have. We have different kinds of data sets in data flows. You can do inline data sets versus you can have a data set created for integration data set. As an example here, this is an inline data set. When we start with the REST API, you can see this is inline dataset reference using a REST API. So you have a bunch of inline dataset references that you can use, which means you don't have to create a new dataset for them, but you can always create, if you choose, you can use integration datasets as well. So this is the difference between inline and integration is the integration datasets expect you to create a dataset already pre-generated, especially if you're working on the same dataset between both copy and data flow. Integration datasets are going to be more helpful. You can parameterize them as well. But if you are doing directly on data flows, you probably don't need to get started with integration datasets. You have an ability to do an inline dataset as well. So you have both these options. So that's where the best practices it was talking about both inline versus integration dataset. So you have pros and cons of each one of them, and you see it right here in front of the screen. The different supported connectors specifically for data flows. Data flows does not support all the hundreds and thousands of connectors, hundreds of connectors, but you can always use copy activity to get access to those 100 plus connectors and then stage the data in data lake, and then data flows can start reading those values. But as you saw, it already supports REST API, supports Snowflake now, supports Cosmos DB, SQL tables, and all those things. You can duplicate data streams, especially when you're working on complex workflows or emitting out multiple tables out of the same transformation step or same data streams. You can actually create duplicates of the streams. You can do joins. You can do all the different kinds of joins equivalent to the SQL join. You can do it visually using the joins in data flows. You can do lookup. You can basically use isMatch function specifically with the lookup transformations for looking up particular rows from a stream. You can do single or multi-row. You can do exist transforms equivalent to SQL exist command that you write in script. Equivalent to that, you can do whether it exists or not, quick validation based on, if you're comparing it with the dimension table, you can actually do exists or not. And based on that, you can have the workflow. Union transforms and similar data from different connection that undergoes same transformations. You can use union for that. Writing multiple data streams into the same sink, you can use union for that too. Conditional split based on certain logic in your stream. Let's say when movies before 1980 and after 1980, you can actually split them into two streams, and you can output it into as two different files, or in two different tables, or you can analyze it accordingly. So if you want to do partitioning of your data, yes, you can use conditional splits and partition your data. Derived column, you can derive new columns. You saw in our example how we actually added a timestamp column and used a function to kind of auto-generate that value. You can use deriving of columns as well from existing or creating a new ones. Select transformations, more like a SQL select statement. You can select certain values that you need. Surrogate key transformations, generate incrementing key to use as a non-business key in your data. It will always increment those values and so on. So there's a documentation you can find on surrogate key and mixture of derived column and a lookup against an existing table. Useful for generating keys for star schema dimension tables. Aggregate transformations, as the name says, you can do certain average or first to collect sum or max and min. You can do those kind of aggregations equivalent to SQL group by clause in a select statement, and you can do the aggregations visually. Pivot and unpivot. Again, if you have certain pivot tables, based on that you want to swap rows and columns, yes, you can do that with the pivoting and unpivot transformations. There's window transformations, which looks at a certain window of data and then runs your logic or transformation logic or sorting based on that, or aggregation based on that. Filter transformations, if you want to filter out certain data based on the condition that you provide, something similar to SQL where clause, you can do that with the filter transformations. Alter row transformations, where you want to do things like insert, update, delete in a database. So for example, while copying the data into your Cosmos DB, you want to delete an existing or modified row or do an upsert for that. Alter row transformations is required, which is equivalent to SQL merge statement. And you will be able to do an update, delete, and all those operations against a database using data flows. Then flatten transformations, which we used in our example. In the complex JSON, we flatten that array into a much simpler order. So when you have multiple layers, deep data, you can flatten that. Rank transformations used when you want to rank based on your existing column data that you have. You want to rank or sort data sets based on certain column names. You can use the rank transformations over there. Parse transformations, basically parsing the string and the current formats that are supported are JSON and CSV. So if you have string in JSON or CSV, this is a proper scenario of a semi-structured data, which is not well defined, but there are certain aspects of JSON and CSVs within the overall string or the file. You can basically use the parse transformation to basically infer the value from the JSON presented from a string. So it's basically useful in converting, turning your plain text JSON strings from a source file in a single column into a formatted JSON output. And the final thing is the sync transformations, which you will actually write at the end to write the data out as a file on a data lake, or writing it out into a database or a data warehouse. One good best practice is never do a writing into a single file, which can be very slow with large amounts of data, because you want to leverage the Spark compute under the hood, which by default uses partitions to make sure that it's using multi-nodes and gets you the right performance. So you have an option of outputting it to a single file, but while doing that, be careful. If it's a small file or small data set, it's still fine. But if it's talking about GBs and TBs of data, it's gonna kill your performance because even though you're using hundreds of nodes, it's just gonna end up using a single node. Sure. So I see a question from Anil is about the inline data sets are rare. Can you can you explain when to use one? Fine. Yeah, I can. So let me go back here into the demo. So what I did is I used an inline data set for connecting to the stress source. And it was simple because when you're starting with data flow, and I'll give you an example when to use inline. When you're starting with this designer, the data flow designer, it is much easier to use inline data sets because let's say I create a new one here, new data flow. You start with an empty screen. You start with the source transformations. You get an option at this point in time saying, do you want to use inline data sets or integration data sets? By default, select as integration data sets. Now, the problem with this integration data set is you have to create a new data set or select an existing one. The advantage or the pros of this approach is you can share the data sets between copy and data flows. But at times when you're not using copy, which means you have none of these data sets created, right? Which means, let's say you started off with data flows today and you have no data sets. This screen will be empty, unlike what I have right now. So in that particular case, you don't need to create plus new, go through these steps saying, I select this, I click on continue, and then I create a link service and all those things. So you see how many clicks you're doing to actually get to a particular file, let's say a log file that I have, I want to access, which contains some data. And inside this, and I click on this and okay, right? So you went through multiple steps and you actually created an entity called data sets, right? And if you want to understand that more in detail, what it did is it created something called data sets, and those data sets can be accessed in your, pipelines. Where is that? Should be accessed. Yeah, it should be here. So linked integration data sets. So what it did is it created a file over here. And you may argue at times that, do I really need this? Or maybe I could have done is I could have just gone to this data flow, selected inline data sets, selected what type it is. And I can say it's basically Excel or maybe CSV, delimited text, and simply select the link service and say where that files are, right? And that's it. So I just have to click 2 clicks and I get started with it. And I can specify this inline in the data flows without having to define a defined artifact called data sets. Like in this particular case, I'm not reusing this. This has multiple advantages. The advantage is it's as it says inline. So all those properties just moves inside data flows. So from the functionality wise, it's the same thing. It's just that it simplifies your experience and you don't have to switch out of the data flow canvas to specify the path and container in a separate entity called data sets. As you did in this, you don't have to do it in data flows. In data flows, you can specify right here, you can browse using this, you can specify the same data in case if it's a CSV, let's say clients, and it's a Parquet file. Damn, I should have change the data set. But let's say I go back here and say it's Parquet now, and let's see the magic. So I don't have to specify anything else. I can access the data, select it right from here, select the particular Parquet file, and I'm good to go. Now I can do projections, I can do import schema from that Parquet file without having to create a integration data set. That's the only difference, right? Now I can also tell you the problems with this approach is if you're sharing data sets between copy and inline data sets or within data flows, I would not suggest you to use this because you will still have to create inline integration data sets for copy to work. Copy does not support inline data sets. This is specific to data flows. So those are the pros and the cons. And it's very simple. You don't really need a documentation to understand this. But yes, you have two options within ADF. And within Synapse, you have a third option as well, which is known as Workspace DB. Workspace DBs are nothing but Synapse databases, which consists of both data warehouse tables as well as Spark tables. So those are those options. And yeah, now get back to the slides. The expression language is very similar both for both pipelines and data flows, though it's different as well because it's running on Spark versus the other one. You can specify dynamic values, expressions whenever you just the way you do in queries and so on, and dynamically replace those values in columns. You can, for example, use derived column. Derived column can derive values from multiple columns like player name, player rating, PTS, and you can append certain strings along with it. So you can create a single expression. You can even do some validations if that player is a good player or a bad player based on the player rating, and then append all this value into a new column. So you can actually do a new column creation based on certain expressions on an existing result from certain columns. Expression language, you can learn more about that in documentation. I'll skip that. We started off with the debug mode where we turned the debug clusters because, as you know, that Dataflow runs on Spark runtime. So it needs a Dataflow debug cluster. So you need to turn this on and you get billed for this period. So you should be aware of that this piece where you're authoring and you turn on the Dataflow debug is not literally serverless, though we will turn it off after a certain time to save cost, but you will be billed for the duration. But it's very minuscule because typically it's a 4-core, 8-core cluster that you need while building your whole UI for doing things like data preview, get schema, and things like that. Debug mode, we already saw that you can do data preview at each and every step. You can do data profiling as well and statistics to understand if there's any improvements that you can do. How does your data look like based on different query conditions, counts, certain values, how's data arranged, and so on. You can do expression output. As we saw when we wrote an expression for timestamp, we clicked on preview and actually showed the preview of that expression. So you can do the same here. Test it out, parameterize the data flows as well. It's a good practice to do that so that you don't have to write n number of data flows, create more generic data flows and use more parameters and pass it from the pipeline into your data flows. Referencing data flow parameters, you can reference it in your expressions. And you can work with schema drifts with flexible schemas. So changing schemas over time, don't have to worry about it. There's just a small checkbox which you have to check. You can use column pattern matching. This is also very useful, especially when you have like hundreds of columns in a particular table. It's going to be troublesome to go through or do a mapping of those hundreds and thousands of columns. And hence you can use some logic based on column pattern. You can specify the pattern, say if pattern is matching this particular value, go ahead and reference it or do certain transformations or actions based on that particular condition. You can do rule-based mapping in a similar fashion. You can map based on certain rules, which when it gets surfaced, that is gonna basically create a new value in the particular column that you are deriving. In this case, it was dropping certain columns which does not meet certain conditions or criteria. And for operationalizing it, you need an activity. So you create a pipeline within Dataflow activity and use the Dataflow designer, the Dataflow that you created on the designer to assign to it. And there's a few best practices which we'll get through in terms of the runtime. In Dataflow, you have this in Dataflow integration runtime, and you have a concept of time to live. If you don't want any latency between runs, what we suggest is use time to live in your Dataflow integration runtime. I can show you here. We also released that functionality in Synapse. So you can go back to the Manage Hub, go to integration runtimes, click on this. You can create a new integration runtime, and I will call this as data flow TTL. Click on you can specify region and then specify the runtime. You can specify what size compute you want. Let's say 16 core. I'm running this, and what type of compute you want, standard or general. And then you can specify time to live. And I will select 5 minutes, not a very big time. You can specify 30 minutes and so on as well. What it means is whenever I'm using this integration runtime in my pipeline to run data flow jobs, it will not shut down the cluster in even after 5 minutes of completion of the job, which means that you will of course pay for that 5 minutes, but that's not the point. The point is that when you run the next job, let's say in next 5 minutes, you're going to run another data flow job. You don't have to pay for extra 2.5 minutes, 3 minutes to bring up the cluster. So your performance will improve by 3 minutes for each of these executions. So especially scenarios where you're executing multiple data flows, right? Not just one data flow, but 10 or 100 or 1,000 data flows in every slices, you might want to use the TTL functionality, because if you chain your data flows one after the other, it'll end up using the same cluster, and it'll add a lot of cost savings. Cost savings in the sense you can control to have only a single cluster, and that single cluster is what is being reused by multiple jobs. And hence, you don't have to pay like 3 minutes of cost per cluster that you would otherwise have created. So if you're talking about 100 jobs, we're talking about 300 minutes of time savings, right? That's a huge amount of money as well as time savings in terms of performance. Okay, now getting back to this data flows, and we talked about the UI that you see in terms of monitoring the data flows. Some of the security considerations or understandings is that in data flows, each of these virtual machines are created on demand. And even when you use TTL, it is used only for your purpose, shared with only your data factory. So it's not kind of shared with different customers. And all the data transfers are protected using TLS 1.2 certificates across Azure. And yeah, that's about it. So we'll move on. And I think we're just closing on the last 10 minutes. So we'll quickly talk about some optimizations in terms of performance. We'll also touch upon CI/CD here. So typically you start testing your transformation logic in the debug mode and using the data preview. That's level 1. Level 2, you test end-to-end pipeline using logic, using pipeline debug. So I'll quickly show you what pipeline debug is. Here in the data flows, I can have pipeline. So we start with data flows. This is where you create a data flow. Once you're done with the data flow, you will create a pipeline. And here's my pipeline. For example, this is my pipeline. I would probably want to do a trigger, and I have a debug here, and I can debug using data flow debug session or activity runtime. So doing this debug using the activity runtime is very useful, because this is how it would, the difference between the two is this will use the actual runtime, which would be used in your operationalized executions, versus this will be a quick execution. So this will basically reuse your debug cluster, which is already on. You can see that debug cluster is on. So when you do a debug with the first option, which is the default option, it'll use that and it'll be much faster. But it might not mean it'll do, because your debug cluster is of different size, right? You can have a different size debug cluster versus you can have a different size execution cluster for your runtime. So that's why we have both these options, and we suggest you use activity runtime when you're debugging it to get the actual understanding about the performance. Coming back to the slides. And then once you verify the data is read and written correctly, use smoke tests before you merge your changes. It's more about CI/CD concepts. We integrate with source control, and through that source control, you can do continuous deployments across UAT prod environments using CI/CD. So you can promote pipelines to higher environments once you qualify in UAT, and then you can promote it to production. For the debug data flow, data preview is inside the data flow design and transformation properties. You saw that uses row limits, so be careful. By default, it uses certain values, and you can improve that values. In the data flow side, you can see debug settings. It says in the debug settings, you can see here's the list of parameters in case if you're using, you can specify values to the cluster. But more importantly, here's the limit that you're setting on your source data sets, which means that for all the debug runs or the debug data preview that you're doing, it'll use only the 1,000 rows. So even if you're doing a transformations, let's say a join based on dimension table, if you're only doing 1,000 row, it might not return all the joins, all 1,000 rows. You might see multiple nulls when you're doing a data preview. In that case, you can always go ahead and increase this value to a higher one. But be careful that the bigger value that you use, the expectation is that you have a bigger debug cluster. If you have a very small debug cluster and you increase this to, let's say, 1,000,000, it's going to take more time and it's going to give you performance issues on your debug cluster. Okay, back to the slides. For the pipeline debug, these are certain steps which I will skip because we only have 5 more minutes left, but we'll be sharing slides with you about the optimization. So similar to copy, you can identify the bottlenecks in data flows as well. So we give you UI visual monitoring, which once you run this pipeline, you can find out what was the startup time of a cluster. You can reduce it by using TTLs, number one. Number two, you can find processing time of sync. If it's slow, you can improve. For example, on source side, you can increase the data warehouse unit or database unit. From third, source read time is each of these rows, however number of rows you read, how much long it took. Then the transformation logic. On the right hand side, you can also see all the previews and steps to understand skewness, kurtosis of your data sets. That can help you improve your partitioning, and you partition in data in such a way that you can get better performance. And with this, I will quickly switch over to some of the things in CI/CD as well, and then I'll go over to the questions because CI/CD is also important. By the way, for ETL, we do have migration partners, especially when you're looking at converting some logic, Spark logic into data flows or visual data flows, or converting Informatica in current pipelines into data flows. We have these partners which automated stuff which can help you automate the whole movement of pipelines, Informatica pipelines into a data flow based pipelines in ADF in an automated fashion. So these are a couple of partners who does that really well. Let's talk about CI/CD quickly. You can do continuous integration and continuous delivery, and this is where your smoke tests and testing will come up. There are a couple of strategies around that. So this is typically CI/CD. You start with the main branch, and then you create a short-lived branch, which is your feature branch or your developer branch, and then you start adding functionalities or pipelines or data flows inside that, and then you do a pull request and validate, merge that into your main branch, and do the code validation, testing, and stuff like that. This is where you might want to do a debug. Of course, debug option is available to test it out locally, and then merge it into your main branch where it's getting merged with other people's code as well. And that is where you want to do a continuous integration build and do a smoke testing. Make sure that the code that you just did a PR and merged into the main branch does not break others and does not break you yourself. And this is where you will do the testing. When it comes to testing, there are a couple of areas how you can test. For example, in your data flows, you can parameterize the source and the sync paths. And you can always pass for debug specific thing, you can use one of the steps in your release pipeline. You can also basically add a execute data flow task. You can call the REST API to execute that particular data flow, which has been merged into your main or published into your data factory. You can execute that using a REST API. So you can actually call that particular data flow, execute that, and get the output of it. That's one strategy on how you can individually execute pipelines and parameterize the data sets. Like my source is a test source when I'm doing this test run. And since you write your pipelines in a dynamic fashion using a lot of parameters, it's very easy to call REST API to do an execute pipeline and get the output of that pipeline to validate that, and then be able to qualify whether the test is successful or not. That is one option. The second option, which customers use today, also is using data flow itself to test the output, validate the output. So you basically write two different data flows, one for kind of a unit testing data flow, and the other one is the actual data flow with the business logic. And you can use the unit testing to use against test data stores, and then output and validate that output within data flows, and then qualify whether the unit test was successful on the pipeline. The pipeline can actually return different values, or you can have a way to invoke a failure on that pipeline in case if it does not meet the requirements. So these are two different ways of using the testing part. What I would do is I would basically add the two links. There are good community blogs around that on how you go about doing testing at a pipeline level in an automated fashion. So I'll basically put the two approaches in the slide when I share it with the organizers, when they share it with you. So you will find that those couple of options in terms of doing testing for data flows. Now we are spot on time. So I'm just going to quickly run through and talk about maybe end the session before that, just talking about what's the advantage you get when you use CI/CD with Data Factory. You have different environments, test, dev, test, and prod, and you can make sure that in an automated fashion, you're deploying code across the different environments. And those are the things which you get. Apart from that, you get a lot of benefits in terms of ability to track reward changes in case if you introduce bugs, which is quite common when you're working in large teams, someone introducing bug in someone else's code or pipelines. And so you should be able to track and audit changes, revert back if required. You get that with Git integration. You can save incomplete work, especially with complex pipelines. That's one advantage. The other advantage is collaboration and control when you're working in large teams. You can get easier CI/CD. You can create release processes based on your requirements. You can even get rid of the publish button click using automated publish. We have recently released a capability with automated publish. We have an npm package which can help you automate the whole deployment continuously, even in your dev environment, without having to click on the publish button. And then you can store parameter files, deployment scripts in the code repo. Everything is kind of securely stored there. Even if Data Factory is deleted by mistake, you can recover it very easily using your source control. And it gives you better user experience and performance. The UI loads 10 times faster with the source controls. These are some of the benefits that you get. I think with this, I will end this session. So we actually went through the 2 hours. We saw some of the best practices with copy, and then with data flows, and then CI/CD. And so with this, I would like to say thank you.